All righty. Early morning, we're going to do a little exponential thinking exercise. All right, this is day 2 of our class, and I've got some tables on the board here. A little break in the wall, and I've got some, I'm calling, instead of X and Y, I'm going to use time. We're going to think about this in terms of time, and our answers in the calculation are amounts based on the time conversion. Okay, so we're going to convert time units to some amount. I don't know, number of sheep and gill, whatever. All right, so you look at the table and see if you can name that tune. And these are, this is an art class. This is a music class. This is singing to me. Is it singing to you? All right, so you're pausing the video. All right, and I'll just keep going. And each time we get a new table, you pause the video and reflect. And see if you can get the brain to start processing some of this material. It takes time. All right, and the only way we're going to get there is to put it in front of you and to practice. Okay, so you're looking at this, and I think the user-friendly numbers are harder to work with fractions. So you're probably looking at the bottom of the table here. All right. And sure does look like 1, 2, 4, 8, 16. Something's happening there. Yeah, sure looks like there's a pattern here. Right? And I hope that you saw it. 2 to the t. Okay. We looked at 2 to the 0 yesterday in class. All right, and a lot of you are probably saying 0. It's not, no. 2 to the 0 is, remember, we said there's the same number of factors in the numerator and the denominator, which means that that's 1. So 2 to the 0 is 1. And what is 2 to the 1? 2 to the 1 is 2. And what's 2 to the 2? 2 times 2 is 4. 2 to the 3. 2 times 2 times 2 is 8, so on and so forth. So that was that tune. Okay, and we're going to play with that tune a little bit. Let's go over here a little bit further. Let's name this tune. Again, these are not the friendliest, but you're pausing the video and you're looking here. Hopefully I've written these down. It's early morning here, so hopefully I haven't had my I haven't had my coffee, so I hope I haven't put anything on the board that's incorrect, but that's part of math, is figuring out when you've made a mistake. So if I have, I'll hopefully pick it up as we go along. All right, so you're pausing the video. I'm just going, well, I'm looking here. All right, I mean, that's the same, but now I'm turning this 10, 20, 40, 80, 160. I do believe that that's still a doubling function, but every single number appears to be 2, 20, 4, 40, 8, 80. Sure seems like I've multiplied 10 times the doubling process. All right, we said the order of operations is we do the more difficult calculations first. So if I put a 0 in, 2 to the 0, 1 times 10, 10. 2 to the 1 is 2 times 10, 20. 2 to the 2 is 4 times 10, 40, and so forth. And so that function looks like it was, first off, my range, which is a description of these y values. We might as well throw that term in here early in the term, right? The term in the semester, early in the semester. It sounded a little better. Early morning, remember. They look like they're all positive numbers. I don't see any negative numbers here. They all seem like they're above y values of 0. Yeah. And these numbers, 10/16 is near a half. That's kind of small. And then I'm going up, whatever that distance is from that line to that dot. The next one is twice that. And the next one is twice this y value. Twice that y value. Looks like it's there. And then whatever that y value is, as measured from 0, is twice that. Boy, looks like I'm getting a graph that's not a line. That's all we graphed yesterday in day 1 was linear. I do think I threw one quadratic at you. I don't know if you remember it. We only looked at it for 10 seconds, but it was a cup-shaped graph, and that came from, you remember what that came from? That came from, I was squaring something. planting some seeds here, but let's go to the next one. So name that tune, we named it. And now you're looking at this table. Oh boy, some things really changed over here. Yeah, I said time, and you know, these look like years to me, and I think we know what our unit of measurement in time is now. We're gonna call our time measurements years. Yeah, 1950, there were 10. Over here, 0 was 10. Remember, you're pausing the video every now and then. Feel free to pause it as I talk and then think again. Well, it seems to me that I want my time, my 1950, to act like a 0. And I want my 1951 to act like a 1. Wow, how could I make 1951 turn into the number 1 and the number 1952 turn into the number 2? Well, I hope, I don't have enough room here, so I'm just gonna write the calculation. Sure seems like we still have a doubling function. Guess I'll put that there. I guess I gotta erase that. I still think we're multiplying by 10 and I think we got a doubling function. But when I put 1950 and I want it to be 0, oh, t minus 1950. I think that's what's going on. Let's put 1950 into our tune. 1950 minus 1950, 0. Doesn't hurt you to hear what 2 to the 0 is again. 1 times 10, up 10. Let's put 1951 in there. Let's drop 19, let's use that year. 1951, the year 1951 minus the year 1950. Year minus year, that unit has been converted to a generic 0. And 1951 minus 1950 is just like the number 1. And 2 to the 1 is 2 times 10 is 20. My, oh my. I'm hearing the tune. Let's keep going. So now my times. Let's get this out of the way because we got to grab the, you know. Looks like instead of every 1 unit, you're pausing the video. 1950 is the same, that's the same. But now, the year 2000 acts like a 1. Well, let's put 2000 in. 2000 minus 1950 is 50. That's not the number 1. How could we make that number 50 the number 1? Well, I can't add or subtract something because then it would make this number not work. What's another way I could make the number 50 act like a 1? And then a jump of 1950 to 2050 act like a 2. So how could I make a jump of 100 act like a 2? And 150 units of change act like a 3. I wonder how I could make those things. Ah, so you're saying 2 times 10 times 2 to the t minus 1950 divided by 50? Oh, that kind of like acts like a metronome on a piano, but we just, instead of going tick tock, we went tick, and every 50 seconds or 50 years tock. Oh, tick tock. Oh, that sounds like something that's out there somewhere. Tick tock. Where have I heard that before? Anyway, now we got another one here, and I'd consider these numbers to be, what's changed? Well, that 1950 hasn't changed, that hasn't changed, but looks like that's changed. Looks like that's changed. Look like that's changed. Oh, so you're saying I could have written this calculation as 10 times 2 to the t minus 1950 over 50 plus 3? That would get me all of these numbers? Let's check 2,100. 2,100 minus 1950, that's 150 years. divided by 50 years. Years cancel. 150 divided by 50 is 3. 2 to the 3 is 8 times 10 is 80 plus 3. Oh, I think we named that tune. Now, how much data do I need here to name that tune? Well, I think it would be easier, since you just started considering this, to take these two data points. I'll just use those two data points right now. I could have used any two, but then again, I wouldn't be doubling things. For instance, if I went from 10 to 40, right? That would be quadrupling things, and that happened every 100 years, right? 1950, that's 4 times, but it took 100 years to make that happen. And in another 100 years, 4 times 40 is 160. So I could have written this tune as a 4 to the t function. I think there's an infinite number of ways of writing those calculations here, which I'm calling tunes. And in fact, there is an infinite way. And what did we say these y values were? Oh yeah, that's the range. The y value is the range. What kind of answers are we getting here? Let's describe them. Well, I think they're greater than 0. So that's the range of this function. Yeah, and they sure look like they're headed somewhere here. Sure look like they're headed to 0 as I go back in time. Those were smaller and smaller numbers, and as I go forward in time, looks like they're heading to infinity. I think they're going forever. And we're going to talk about those. Oh, I just described something happening, so there's got to be a name for it in math, and really a discussion about limits. What's the limit to this growth? There is none. It's going. It's going up. There's no limit as we go into the future. In the past, yeah, there's a nice limit of 0. Right? We're heading to 0. These numbers are getting smaller and smaller because, if I look at 160 to 80, I'm cutting things in half to 40 to 20 to 10. And you keep cutting things in half. And ooh, it's like the Wicked Witch of the West. I'm melting. I'm going to the floor. Yeah, you can tell it's early and I haven't had my coffee. All right, so what's it take? It takes an asymptote. So if I give you an asymptote, in this case, let's say it's 0. No, I didn't give you an asymptote of 0, right? Excuse me, I got to be careful here. I raised this by 3 units. Right, I raised this by 3 units, which means we aren't at y equals 0 anymore. So that was told you I was going to make a mistake somewhere. I always do. Because I'm talking and I don't do so well just talking and doing the math anymore the way, years ago. A little sharper. It's disappearing. Okay, so this function has an asymptote of 3. We're never going to get below the number 3 because I added 3 to what used to have an asymptote of 0. Let's get rid of all the junk here. That function, no, I don't even have it written anymore. T minus 1950 over 50 is only giving us positive numbers that are heading to 0. Over here, I added 3. So that's my new asymptote, y equals 3. And let's get 2 points here. Let's get 1950. Gets us 13. And 2000 gets us 23. And I want you to be able to take an exponential function. And I give you 2 points and an asymptote. And I want you to be able to write it quickly and easily. And our Algebra 1 class last semester did. It took several weeks. But most of the students were able to write those in 10 seconds or less. And that's what our goal is. And the only way we're going to get there is to start the discussion. And we just started the discussion. And the rule of 4 is I give you, 4 days, about 5 minutes a day, maybe less than that, 3 minutes a day, 4 days in a row. And generally speaking, by that 4th day, if you're paying attention to what you're doing and really giving it some, 3 minutes of effort, 4 days in a row, what I've seen over the years is folks start picking up on this. So let's see, what do we start with? Well, let's start with the easiest thing. Everything's above 3. So let's start our equation. Let's say y equals 3. And then the question is, well, I think I'm going to do it slightly differently here. I want to give you they say pictures are worth 1,000 words. So let's actually get a picture going. That's going to be a lot easier. So exponential functions they're based, the calculation is based on the constant. And the constant in this case is 3. And 1950 gets us 13. But I'm just going to write the number 13 right now, because these are the y values, and we're writing y equals. Let's do it here. I'm writing y equals, so that the first y value that I'm giving you from left to right is, and yeah, you can see that, is 13, and the next one is 23. And what's most important is the difference. I'll write y equals 3 here. I'll write y equals 3, y equals 3, right? So y equals 3, to get to 13, it's a jump of 10. From 3 to 23 is a jump of 20. Okay, remember, that's where we started. That's the base of this exponential function. Guess where the base of an exponential function comes from? These are called differentials, differences. Difference 1, difference 2, those are called subscripts. Where's the number 2 come from? The second differential divided by the first. If we talk about that every day, do you think you're capable of getting it? I have faith in you. I think you are. All right, so you have to look at those y values, and you have to look at the differentials. All right, and so therefore, we start with 3. Okay, let's do it this way. In case the numbers aren't friendly, we start with the constant. That's step 1. Okay, let me see. There's 1, 2, 3, 4, 5, 6 things you have to learn mechanically to do this, and then we'll keep talking about it conceptually. But 6 things. That's the first, identifying the asymptote that I give you, and you just write it. Step 2, look for, from left to right, one y value to the next, and say, how do you get from 3 to 13? Well, you add 10. The next time we don't add 10, you're going to get rid of that first differential. You're going to write the second one, and you're going to put it there. Now we go to the exponential aspect of this. So let's write, instead of y, let's go a of t. That's what we called it before. All right. And to get that first jump of 10, right, to get that first jump of 10, that implies this has to equal 0. That implies it has to equal 0 because 2 to the 0 is 10 times 1. And if we add 3 to that, that's what takes us to 13. So I have to make my first input the number 0, but my first input is 1950. So minus 1950. That makes it 0. And this class is based on zeros and 1. And b to the 0 is 1. And b to the 1 is b. That simple knowledge allows me to write this as quickly as the equation of a line when you get experience with it. And the only way you're going to get experience with it is to think about it and get a lot of repetitions. It's the only way you develop skill in a sport. Repetitions. Folks that get the reps do better than the ones that don't. That's true in this class. Those of you who get the reps and work with them will continue to make just steady gains right along the whole semester. It's toughest at the start. Okay, and then we look at, well, how long did it take to get our doubling from 1950 to 2000? Well, that's where we get our change of 50 years. And that's what we just worked on as we did our progression. My suggestion to you is stop the video, go have a nice little walk, chat with a friend. Just don't put the phone in front of you when you're chatting with your friend. And then come back to it tomorrow. Play it again. Play it again, Sam. All right, but we'll do one more problem. I'll just make a random one that isn't as nice. All right, because if that went to 24, I would have had to make a 21 here, right? just a little bit more than doubling, because instead of 23, I went to 24, a little bit higher. All right, so I'll try to give you a canned one, so the numbers are nice, and we're just looking at exponential growth right now. All right, so I'll give you the graph. Let's say y is equal to 5. There've always been 5 sheep and gill. We're gillbillies here. Exponential growth. But in the year 2000, ooh, there was a big population growth in the number of sheep and gill. We went up to, let's make it 12. 12 sheep and gill in the year 2000. Yep. And then 26 sheep in the year 2023. Oh, it's 2024. Woo! Boy, everything's got to change now. 2024. Happy New Year. Now we got, what did I say? Well, I can do it again. 21, 26. All right, you can pause the video and see if you can get past, step 1. Hope you got step 1, and I'll do y equals. Right, you're pausing the video. Step 1. I'm measuring all of this change from the constant, and all of my answers are going to be bigger than 5. That's my range. Remember I said there have always been at least 5 sheep and gill? Okay, more than 5. Those critters, I like sheep. Okay, well, how far is it from 5 to 12? That's a population boom of 7 sheep in the year 2000. And we're going to make 2000 become the number 0. Yeah, but we're not there yet. We're going to get the rest of this y stuff taken care of. So, boop, 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 boop. There's your first differential. What's your second differential? Boop, 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 boop. From 5 to 26 is 21. Oh, it's not 7, it's 21. Of course, I think you probably might write the number 3 in that parentheses, because I think we got a tripling going on here. Yeah. Okay, so our exponent, we want the year 2000. I don't think I want to do 3 to the 2000. But I got a marker. Let's cut this down to size. Now, when you drop 2000, in for t, 2000 minus 2000 is 0. This course is based on zeros and ones. 3 to the 0 is 1. And 1 times 7 is 7. Plus 5, 12. I just made the number 2000. Give me the number 12. Now, if I can just throw 2024 in there. 2024 minus 2000 is 1 tripling. I want that to be, right now, it's 3 to the 24, but I want that to equal 3 to the 1. Well, I think dividing by 24 gets that job done. So it seems to me every 24 years, our sheep population is tripling. This is really good. Nice to see those little guys running around. So that's that function. Now, we're going to do one of those every day now for the rest of the semester. You know, just 1 or 2 a day. And then if you have real trouble with it, then we'll start doing 5 or 6 at some point. But you got to let the brain sort it out. You got to be patient, and you got to be curious. You got to be willing to reflect. All right, I'm on a rant. I almost feel like doing one more, but I think I'll stop it right there. I want to have you, start thinking. All right, up and running. Thought exercise. Have a good day.